I will be explaining how to balance redox reactions. The first thing to know is how to balance a half reaction. You start by balancing all atoms aside from oxygen and hydrogen atoms. After that has been done, you can balance oxygen atoms by adding H2O molecules to the side that has the least amount of oxygen atoms. And you can balance hydrogen atoms by adding hydrogen ions to the side with the least amount of hydrogen atoms. Once all the atoms have been balanced, you add electrons to balance the overall charge of the half reaction. You add the electrons to the side with the greatest charge, or the most positive charge. If the half reaction occurs in basic solution, you will need to use the water equilibrium equation to cancel out the hydrogen atoms. As an example, we are told to balance the following half reaction. So you start by balancing the atoms that aren't oxygen in this case. So in this case, we only had to balance the nitrogen atoms. So now we can balance the oxygen atoms. On the left side, there is a total of 6 oxygen atoms, and there's only 4 on the right. So you must add 2 H2O molecules to this right side. Then you must balance the hydrogen atoms. There are 4 on the right and 0 on the left. So you add 4 hydrogen atoms to the left. And now you add up the charges on both sides of the equation to see the difference. Now, the right side only has neutral molecules, so the overall charge is 0. Whereas on the left, you have a positive 4 charge from all the hydrogen atoms, and you have a negative 2 charge from the nitrogen molecule. So that gives an overall charge of positive 2. So you need to balance that out by adding 2 electrons to the left side. And always make sure to double check your work in case you've made an error. So on the left side, we have 4 hydrogen atoms, and we see that there are 4 on the right as well. Where there are 2 nitrogen atoms on the left, and there are also 2 on the right, there's a total of 6 oxygen atoms on the left, and there is a total of 6 oxygen atoms on the right as well. This equation is balanced. Now that we're familiar with that, it's time to balance a redox reaction. The first method uses half reactions. So you first break the given equation into 2 half reactions. Then you balance these half reactions individually. The number of electrons lost must be equal to the number of electrons gained. So once you've balanced the half reactions, multiply them by appropriate whole numbers so that number of electrons lost is equal to the number of electrons gained. Once that has been done, you add the 2 half reactions together and you cancel out the common species and electrons. If the reaction occurs in basic solution, again you must use the water equilibrium equation to cancel out all the hydrogen atoms. So, as an example, we're told to balance this equation in basic solution. So you start by going into half reactions. Then you balance these 2 half reactions. Oh, I realize I made a mistake here. So we now have the two balanced half reactions. And with the manganese half reaction, you see that it gains 3 electrons. And then with copper, the copper half reaction, you see that it loses an electron. So you cross multiply the two equations by these coefficients. Multiply the copper by 3, multiply the manganese half reaction by 1. Once you've multiplied them, you add them together and cancel out common species. It's easier if you line them up, so be sure to do that. Now we see that there are 3 electrons here and 3 on the manganese half reaction, so you cancel them out, and then you add the two half reactions together. So, now this equation would be balanced, but we are told that the equation is in basic solution. The reaction occurs in basic solution, so you must convert it to basic solution. And you do this with the water formula. So there are 4 hydrogen atoms here, so we must have 4 here. And to balance out the equation, you must balance out the water equation. Then you cancel out the common species. So cancel out the hydrogen atoms. The water on the right is canceled out. And once all the common species have been canceled out, you can add everything together. And this is the half reaction. This is the balanced reaction that occurs in basic solution. And as always, you must check to see if the equation is balanced. There's 1 manganese atom here and 1 on the right. You have a total of 6 oxygen atoms, and there are a total of 6 oxygen atoms on the right as well. 3 copper atoms on the left and 3 on the right. 4 hydrogen atoms on the left and 4 on the right. Do note that there can be a redox reaction where there is only one reactant, which undergoes both oxidation and reduction. This type of reaction is known as a disproportionation reaction. You balance it the same way you balance any other equation. So the second method for balancing redox reactions uses oxidation numbers. You first calculate the oxidation numbers of the species present. Then you calculate the change in oxidation number. Then after you've calculated that, you cross-multiply each half reaction by the change in oxidation number. Then you must balance the charge by adding hydrogen ions if the reaction is acidic, and if it's basic, you add OH instead. Once that has been done, you can add H2O molecules to balance out either the hydrogen atoms or the OH atoms. As an example, we are told to balance this equation in basic solution. So you first calculate the oxidation numbers of all the species, or specifically the change in oxidation numbers. So manganese is positive 7. Negative 8 plus positive 7 equals 1 negative charge, as we can see here. Oh, that's an awkward copper. I'll fix that. Copper 0, there's no charge. It's negative 4 from the oxygen, so this is positive 4, and we have positive 1. So the manganese overall change in oxidation number is, change in oxidation number is negative 3. Copper, the change in oxidation number equals positive 1. Next, you multiply each of those reactions by the change in oxidation numbers. So manganese half reaction is multiplied by 1. Copper half reaction is multiplied by 3. Alright, so the change in oxidation number for the magnesium half reaction is 1 times negative 3. It's negative 3. So the change in oxidation number for manganese is 1 times negative 3, which is negative 3. For the copper, change in oxidation number is 3 times positive 1, which is positive 3. So the total change in oxidation number is 0. Now you just multiply them, the half reactions, and add them together. So we have, 3 copper times. Now you add up, now to balance the charges, you add OH, since we are told this reaction occurs in basic solution, so we must add OH if the reaction is basic. So if we look at the right side of the equation, you have a positive charge of 3. And on the left side, you have a negative charge of 1. This means that you must add 4 OH molecules to the right side. Right, I should do that in a different color, just so you can see it more clearly. So you have 4 H on the right side, and then you have to balance out the OHs. So there are 6 oxygen atoms on the right side, 4 on the left, so you add 2 H2O molecules. And then you check to see if the equation is balanced. There are 4 hydrogen atoms on the left, 4 on the right. There is a total of 6 oxygen atoms on the left, and we also have 6 on the right. There's 1 manganese atom on the left and 1 on the right. We have 3 copper atoms on the left and 3 on the left. 3 on the right, my bad. This equation is balanced. And that wraps up how to balance redox reactions.